Um, there are n cars given at miles given. There are n cars at given miles away from the starting mile 0, traveling to reach the mile target. You are given two integers arrays, position and speed, but of length n, where position I is the starting mile of the ith car, and speed I is the speed of the ith car in miles per hour. A car cannot pass another car, but it can catch up and then travel next to it at the speed of the slower car. A car fleet is a single car or a group of cars driving next to each other. The speed of the car fleet is the minimum speed of any car in the fleet. If a car catches up to a car fleet at the mile target, if a car catches up to a car fleet at the mile target, it will be considered as part of the car fleet. Return the number of car fleets that will arrive at the destination. So that's one fleet. Car starting at 0, speed 1, does not catch up to any other car, so it is a fleet by itself. The car starting at 5, speed 1, and 3, speed 3 become a fleet, meeting each other at 6. The fleet moves at speed 1 until it reaches target. What if the cars like pass each other? Like, miles per hour. Or I guess if it tries to pass, like it cannot pass. So if it's like, if it reaches, right, if it reaches the other car, then it just like connects with the other car, like becomes a fleet and then travels at the same speed as of the Slovak car. Okay, so we read the question, we did a target. Just to go over this, let's write out the function signature. We have a target. There are n cars. Are we given n as well? I don't think so. So we have a position. Let me actually just write the type as well. Position would be a list of integers. Yeah, car. And then speed also being a list of integers. And then we want to return the number of car fleets, so we have an integer like that. And then I guess I'll just like revert that. Beautiful, yeah, that's the exact same. Awesome. Okay, now just going over some questions. The target, can it be 0? Like, what's the range of the target? Given miles. And then what's the, like, how many cars can there be? Can there be 0 cars? Right? How would that work? I guess there would just be 0 fleets that arrive at the destination then. What's the maximum number of cars? Positions and speeds would be relative to, would be length of n. I'm assuming there's a range on what the elements can be. Probably can't be less than 0. And position can probably only be, can it be past the target? I don't know, maybe I didn't read that properly. But yeah, can it be past the target? And speed, what if the speed is greater than the target as well? So just some considerations. Yeah, those are my clarifying questions. Let's see what it says. Oh, there's more examples too. Maybe I'll read that. Yeah, just one. There's only one car, hence only one fleet. There are 3. Target 100. I'm seeing the positions and speed are much lower than the target. Car starting at speed at 0, speed 4, and 2, speed 2 become a fleet, meeting each other at 4. The car starting at 4, speed 1 travels to 5. Then the fleet at 4, speed 2, and the car at position 5 become one fleet, meeting each other at 6. The fleet moves at speed 1 until it reaches the target. Okay, cool. So n is equal to position.length, speed.length, yep. And so there has to be at least one car. It could be up to 10 to the power of 5. This is useful to know. I wouldn't say this in an interview, but this is useful to know because now I know that there's probably more of an optimal solution, not just a brute force solution that we want to go for because this number is just so high. Target can be 0, okay. 10 to the power of 6, position eyes, 0 to, and has to be less than target, and speed, speed can be really high, interesting. All the values of position are unique. Oh, I didn't even consider that, whether they're duplicates or unique. I should probably start considering that. That's the second time I've forgotten about the duplicate scenario. Okay. So I know this is a stat question. I chose it from the stat category on NeetCode. Now, but how would I actually solve this? Just kind of looking at this question as a human, not even like thinking about coding. I see the target is 12, right? I see these are the positions, right? Like, I would probably draw like a graph of some kind. Can we start at position? We can't start at position 0, yeah. 7, 8, 9, 10, 11, 12, right? Like some kind of number graph. And then kind of just note down the different positions. So I'll just note them down with numbers. So we have car 3 here. We have car 5 here. We have car 4 here. We have car 2 here. Oh, whoops. 2 here, and then we have car 1 here. All right. So car 3 can move at speed 2. All right, so on the next iteration, it would be here, right? For car 5, hold on, sorry. Car 1 moves at speed 2. So it reaches the target there. Okay. Car 2 moves at speed 4. 1, 2, 3, 4. So when this moves, did these two become a fleet? If car catches up to a fleet at the mile target, it will still be considered as part of the car fleet. Yeah, so it catches up at the target, so these two will be considered as a fleet. All right, so fleet, 1, 2, so far, and I guess I can add to it. Oh, let's see. Anyone else that can catch up? So on the next stage, we have 3. 3 is just 1. 5 is 4 is 1 as well. 5 is 3. 1, 2, 3. So they catch up, and this will be a fleet as well. 4, 5, and then 3 can just be on itself because it'll just be 1 by 1. So क्या हुआ?
काम कर रहे हो? गए थे आज?
कहाँ जिम?
हाँ जिम?
नहीं, कल जाऊँगा. Yeah, probably the best diagram, but it works. It's, so okay, so as a human, I'm doing this, kind of drawing a number graph, and then just you know, keeping track of the different cars and all that. How do I translate this to code though? Like even just as a brute force, not even thinking about stacks or anything. We have n cars, we need the n cars to consider. Um, yeah, this is hard. I'm thinking like we have 5 cars. Okay, the cars can move. When a car matches up, right, somewhere before or equal to the target, right, at time before or equal to the target, then they count as a fleet. So, and then how can you track this fleet? Like, that's confusing as well. So we'll need like a timestamp like this. I'm thinking like maybe like a dictionary. At each timestamp, put your original car, and then do like an update, right? Update, and then when you update them, see at each stage which cars line up, then add them to the fleet, and then get rid of like when these two kind of reach, get rid of the fact 5, like choose the minimum speed out of all these cars. The minimum speed will be 3. 1. So yeah, so dictionary, the keys, right? The timestamps, the values would be the cars. I have like an update. It'll update the speed. And then where do you keep track of the their speed? And I guess we have the speed list, but we probably need like a fleet speed list.
क्या हुआ? मुझे लग रहा है उसमें गंदे कपड़ों में हमारी इसकी फिटेड शीट है ग्रीन वाली वो बिछाओगे ना बेटा नीचे मैं अपने पास रखती हूँ चादर वाली मेरे पास तो नहीं है ना तो बेटा उसको धो लो और इस्तेमाल करो
ओके
ठीक है
ठीक करता हूँ
बेटा ऊपर की सब वो ग्लास वगैरह साफ करना है तेरे को
ठीक है What was I gonna do? Right, fleet speed. Or maybe if I have permission, I can change the speed of the car that's added to the fleet to be the minimum. Maybe I can like mutate the parameter, but probably not best practice. Position we just need once at the beginning. Yeah, that's what I think. I mean, with that brute force approach, I guess time complexity, space complexity. Space complexity, we store the timestamp of all of this. Oh, then so it's gonna be like O of target times n. reason why I say n is because that's the number of cars that we're saving as values. But maybe it's just target like that. And then time complexity is... We set this up. At each stage we update. We take the n cars and update by their relative speed. Worst case, each one is going at a speed of their choice. We have n cars, each going at speed of 1, maybe at different positions. So it would be like n times speed of n. That's kind of confusing, but it's the best I can do at the moment. Now, stacks. Where does stacks kind of fit into this scenario? I don't know. Yeah, I don't know. Well, we are at 22 minutes, so I think this was a good set. Like, I got like a brute force kind of. So I got something, which is nice. Where's the, like... So, what I do when I look at stacks, just some things I've noticed. There's a lot of, like, parentheses questions, right? And when there's parentheses involved, then there's usually some form of stack. Like, when there's, like, an opening and a closing parentheses, then you can potentially use a stack to make your life easier. I've noticed that. Here, is there anything that I can like push and pop in a stack like matter? Can I do time? Can I do the cars? Do I keep these cars? I can't keep these cars in just one stack. Maybe it's the visual that's like throwing me off. Do I need like a different... Do I need to look at this from a different perspective? The fleets are different as well. And then, yeah. This as a stack? No, that doesn't make sense. No, I don't see it. Okay, let me watch the Nikon video and see what they end up doing. Good attempt. Good attempt.